All right. Hey, everyone. Welcome to the launch of SST Jobs. What is a job? Uh, a job it is really just a simple way to run like a long running jobs. You can provide it a function, and the function can look exactly the same as your lambda handler function. And when it gets invoked, it can run up to 8 hours. You know how Lambda can only run for 15 hours and you would time out. A job can run up to 8 hours. Um, Let me post a link to the doc uh, in the chat, and you guys can look at it as we go through the stream. So what can you do with a job? You can use jobs to do video processing, or like machine learning jobs, or like ETL jobs, or if you want to load large amount of data into your database. So essentially anything that can take longer than 15 minutes. That's what the lambda, the boundary limit is. Um, I really like to thank everyone that gave us a lot of good feedback on Twitter, in our Discord community. And I know some of you pointed out that in many cases you can break down a function into smaller steps, right? So you're not running like a job that lasts a couple hours. You chop it up, and usually you can actually chop all of these things up into smaller steps, and you can run each step inside a lambda function. Yes, you can do that, and that requires some upfront work to orchestrate all the little steps. You could use step functions, and some of you might use AWS batch, right? Definitely, you can use all of them. But in a lot of cases, it's the feedback we kind of got from Twitter and on Discord, is that you might not want to do a lot of these upfront work for these one-off jobs, or like a nightly job that is not really mission critical, that you care about performance. So you just want to throw something in, just like, hey, just run this for me for a couple hours. So I like to for you guys to think of jobs as an escape hatch to run anything that would time out if you run them inside lambda functions. All right, let's jump right into a demo. I'll pull up my screen, and then we'll do some live coding and then see how do we use the job. How do we invoke a job through like an API endpoint. Yeah, let me pull up my screen. Cool. All right, the first step we're going to do is we're going to create a very simple, like a very minimal TypeScript SST starter template. Let me post a link to a starter. It's on in the GitHub repo. So if you don't want to actually create one, you could just pull this up and then look at the file structure, and everything should be there. All right, let's start. All right, let's start by creating a new SST app. So we're going to create SST latest. I'm just checking my phone to see if anyone's saying anything about cannot hear me or no. Cool. Nope. All right. We'll create a minimal template, and we're going to pick the TypeScript starter. And let's call it job demo. The reason we're picking a minimal starter is, let's install dependencies. It will take a little bit. The reason I'm picking the minimal template is it's very clean. It's always a good starting point if you already know SST and you want to test out like a new construct, or it's just like really clean. There's not too much things going on. But if you're creating a real project, we highly recommend you to use the GraphQL starter. And the reason I'm picking the TypeScript starter is we actually put in a lot of work to make the whole job experience type safe, which we're going to show you in a couple seconds. And all right, it's created. Let's load up our editor. What I'm doing, our editor. All right, here it is. like I mentioned, there's really two folders in this brand new SST app that's of interest. One is stacks, one is services. Stacks contains all your infrastructure code that are going to be deployed to AWS as in a CloudFormation template. And services are your Lambda functions. And in this case, we also have our job functions here, but they are just application code. Let's take a quick look at what the stack looks like. We are defining just one stack in here. Okay, let's go into our stack. We are going to create, let's add a job in here. You can see the starter, like when you create a new starter project, you always just deploy one endpoint, and you can curl it right after deploy. It should work. But in this case, we're going to create a job. Let's call it a new job. Let's name this my job. All right. So you use new job when you want to create a new job. And we need to implement this, import this construct up top. So it's part of the resources package. The resources package have everything that you need to build out the infrastructure. We are going to point to, where is the handler function. If you look at this API where you're just passing a path to the handler function, it's exactly the same with the job, and we're going to see the actual handler function will look exactly the same as a Lambda function. All right, so we're going to point the source path. The reason we're pointing a source path is that we have a package JSON inside services, so we are actually just file structure. We're actually dividing up into stacks and services. And service, it's a monorepo service. It's a standalone npm workspace, and with its own package JSON. So we're just telling it where to point the root of the services are. And you have a handler function. It doesn't exist yet. We haven't created yet, but we are going to create one inside functions, and we'll call it my job.handler. All right. If you have created functions before, this looks very similar. Like we made it exactly the same on purpose. All right. Okay, and so that's it. That's all you need to define a job. Let's go implement this function, my job. We'll go into services, and then inside functions, see we already have a lambda.ts, which is handling the endpoint for our API. We're going to create a sibling to him called myjob.ts. This over here, we're going to create, just like the Lambda that's handling API requests, we're going to create a similar Lambda that's going to handle a similar function that's going to handle this job. Let me cheat a little bit. Let me just copy and paste the code I had previously. Cool. First, we're going to import the job handler. We're importing it from our node package. Just keep an eye on when you import from resources, you're always using this package when you try to create infrastructure. And if you're inside our application code, we have a bunch of helper functions that you can import from serverless stack node. And so we import job handler, and we're going to make our handler do something very simple. Is you're going to pass in a number, and it's going to calculate factorial. And I'm just putting something in that shows it needs some computing power to do this task. But for your job, it could be something that runs machine learning. It could be video processing. Something runs like forever, a couple hours. And cool. And we are also going to define what this payload is going to look like. And we're going to define this payload to be the payload for my job. We're going to have one number in there. It's called num. It's going to take a number, and we're going to calculate the factorial of this number. You can see the red line here because we have not npm installed this package yet. let's go into our services folder, npm install. Let's save it. Node. We're going to install the Node packages. There are a couple packages inside Node. There's a job, there's config, there's GraphQL, there's auth. In this case, we're going to just import from job. All right, now all the type errors are gone. You can see there's a type error here. That's because we haven't built our app yet. So we will run npx SSD build. The stage name, I'll give it my stage. All right, when it's built, all the type errors are gone. And now let's do a SSD start. Let's start up our local environment. While it's starting, let's take a look at why the error was here. Why is it gone? It's because we, like I mentioned, we put in a lot of effort to make everything type safe. So you define the name of the job type here. And if you, by mistake, you access instead of num, which is expected to be a number, but if you access something payload.foo, it would say, hey, foo does not exist. You only take a num. So everything's type safe. You just define the shape of your payload in one place, and it's being used in a couple of places. It's being used here in the job handler, and I will also show you that if you were to invoke this job through an API, when you invoke, you can pass in a payload, and that's also type safe. Show you in a second. All right. If you look at our live Lambda environment started up, let's open up our console. Oh, console's up. You can find your jobs under functions. We put them inside the functions for two reasons. One is they are really just functions, right? Just you see this. This is very similar. We just wrapped around it to provide type safety, so everything is typed automatically. But behind the hood, how your Lambda function takes an event and context. In this case, we're not passing a context, but this payload is really just your Lambda event, and this function it should be just really literally just your Lambda function. So you can find my job here. A second reason we put under functions is later on we are thinking of adding a jobs tab that kind of help you manage how many times did this job pass, how many times did it run in the past. You can look at all the history, and which one succeeded, how long did each one take. On a roadmap, if something, play around with jobs, if that's something you're interested in. If something you want, just let us know on Discord, and we're going to bump it up on the priority list. Cool. The job takes, like we define in our type, it takes a num, and we'll pass in 10. Let's invoke it. All right. This is just like your live Lambda development. This is run on your local. And so this job code, we just executed on your local, right? Because we're running SSD start. Cool. This is all hooked up. We just created a job and we implement the job handler. And let's look at, let me take a quick look at my notes. Is there anything I missed in this? Oh yeah. When you define this job, very similar to a Lambda function, you can define, hey, I want to set a timeout. I want to set if my script is doing a lot of it's really resource heavy, you can give it more memory sizes. So you could do all of that, just like how you're defining your your Lambda function. Timeout, I'm gonna give it, you can, by default it's 8 hours, you can give it 2 hours. Memory size, you can see what are the options he has. We are using, the service we're using, I'm going to talk about that in more detail. The service we're using is CodeBuild, so it doesn't have as granular of the memory size options as Lambda functions, but it's still quite flexible. It starts with 3 GB and you scale all the way up to 145 GB. And by default, it's picking 3 GB. And you can say, okay, I want to pick it 5 GB, right? Sorry, 15 GB. And very similar to a Lambda function, if you need to access other AWS resources, let's say in your job, you need to write to the database, get some file from S3 bucket. You can give permissions. You can say, I allow my jobs to make calls to S3 permissions. And also if I want my job to, let's create a topic here. And if our job want to fire like a SNS topic, could call my topic, right? In the config, you could pass in a config. You can pass in new. I'm gonna import config here as well. You can import new config. It might look better if I wrote it as a separate line. So I'll do it here. Topic ARN equals to config parameter stack. We'll call this and give it a value of topic dot. And then you can pass that right in here, so that maybe here I'll give it SNS permission. So what this does is in your job code, you could after you calculate factorial, you could get the topic ARN from config, and then you could do fire send a message to this topic, so you have permission to access the AWS resource, right? So pretty much everything you can do inside functions, like not everything, but most of things you can do it here. For the things that we don't support yet, like currently we don't support VPC, Lambda layers that we don't support, but if it's something you need, let us know in Discord, we can add it. Right, even Lambda layers, I think we might be able to find ways to to figure out how to support that using job. But anyhow, these are the set of parameters or properties a job currently can take. All right, let's get rid of them for a second. Cool. All right, we're back to this job. Now what I'm going to show you is what we just did is we invoked this job through the console, right? But sometimes you want to hook it up to an API, you want to hook it up to a cron job. Let's say every night you want to import or export some data from a database, the job can run for an hour, so you want to have a cron job to invoke this job. In this case, since we already have an API right here, I'm going to show you how to have the API invoke this job. It's if you're familiar with SST, this should be very easy. Is you do attach permission and you pass in the job. So you're saying API now has permission to invoke this job, right? That's everything you need to give the permission. And let's go to services, functions, Lambda, right? This Lambda again is the one that's the Lambda function handling the API endpoint. We'll go in there and we're going to say that's job dot. Well, it's imported job for me automatically. We're gonna run our job from here. Notice how it's auto-completing, saying, hey, it's my job. So everything is type safe across board. If you renamed it my job, you cannot name it your job. You're going to get an error here. You can get a type error here, right? So, right, you pick my job, and we're going to pass in a payload, which is a payload, and you're going to pass in a number. Again, if you try to autocomplete, you can see it's suggesting we need a number here. We're going to pass in 5. That's it. Cool. And that's it. That's it for us to be able to run the job. Since we added a permission, is going to it needs to redeploy. So let's just press enter to let CloudFormation do its things. Give it some IAM permission for this Lambda for the API to be able to invoke the job. But while it's deploying, let me just show you if you do my job 2, it's going to say, hey, it's a type error. You have to call it my job. And if you call it foo, give it 5. And again, it's going to complain and say, hey, this payload does not take foo. It can only take a parameter called num, and it has to be a number. Okay? Again, and all that, source of truth where the type is being defined is here, the lambda, the job handler function. Okay, and just to show you, if I call this foo, all of a sudden you get type errors everywhere, and you name this foo, everything's fixed, right? So so it's from now on, everything we're building, we want to all the construct we're building now, we want to make sure this type safety idea is baked in to all the constructs. And I'm sure we're going to take effort to also add this type safety to some of our existing construct, like the bucket API. Cool. Let's name back to none. All right, you can see it is done deploying, and let's invoke this API. All right, we're going to invoke this API. You can say, okay, your request was received. This is what the function looks like. If you go into the API route, you can see a request just came in, and cool. Yeah, so the request came in, and that should have triggered the job. If you go into the job page, there, the job was triggered with a num equal to 5, and you calculate the factorial of 5 is 120. Yeah, I think that's everything I wanted to demo. So at this point, again, just a quick recap. What we have looked at is how to use the job construct to create the infrastructure for a job. If you want to know what's being created behind the scenes, stay around. And then we also looked at how to define, how to create a job handler. You can use this helper function, and the content of the handler is really just a Lambda function. Again, you can define the type here, which will make your payload type safety across where you're using it, where you're invoking, where you're passing it in, and where you're consuming it. And finally, we looked at how to use job.run to run this job from anywhere, from your cron job, from an API endpoint, from your SNS subscriber, a queue consumer, Kinesis stream consumer, anywhere using a Lambda function, you can call job.run. You can even run a job inside another job, right? Just don't do it recursively. Cool. That is everything I wanted to cover for demo. Oh, so I guess one last thing is, if you kill this SSD start, let me just quickly show you what the console experience look like after you deploy to prod. So we'll deploy to live. So when you run SSD deploy, you can pass in, let's say, stage to prod. We're going to deploy the same app to the prod stage. Let's give it a second to deploy. What I'm going to show you is what the console experience is going to look like. give it a second. Let me see if there's any questions in the. Cool, no questions. I don't know if that's a sign of me doing a good job or a poor job explaining job. Okay. Right. Should be done fairly quickly. Let's give it a couple more seconds. Just take a look at my note to see if I missed anything. Cool. While it's deploying, let me just reiterate the steps you need to do. So step 1, create a job construct. Step 2, give permission to whoever you want them to invoke their job. Step 3, create a job handler. This is in your application code. Step 4, go to wherever you want to invoke this job and call job run, right? The 4 steps. And again, if you look at the link I shared in the doc, those are the exact 4 steps I documented in there. Cool, it's done deploying. Let's now pull up. Let's run the console in the production mode. Okay, let's refresh this page. Cool. See the local tab it's gone. This is when you know that this is in the production mode, not in the SCC start mode. Again, you have the API, you have the job. We're going to invoke our job in the exact same way with the same input, same payload. We'll say invoke. See the jobs, they are not coming in right away because this is not running on our local anymore, right? We just deploy to prod and we are running in prod. Like I mentioned, behind the scene, it uses this AWS service called CodeBuild, and it's printing a log because it's not a lambda log. So we haven't implemented the part of the console where ideally we want to show you the logs in place. We haven't gotten to that yet. But we threw you a link where you can go into your AWS console and check out the log. Let's go in there. I don't have all the rows configured. Let me switch to Safari. Okay. Going to my playground. Everyone should have a playground. And let's copy this link again. Oh. All right, you'll go to the AWS CodeBuild console and show us the job. It said it succeeded. Okay, just some glitch on their side. It's not being printed out. Okay, see, if you go to the CodeBuild console, if you just go to the link that gets printed out after the job after the job starts up, you're gonna print a link to the actual CodeBuild job page. You can click through, and there are a bunch of things saying, "Oh, this build container is starting up," and you can ignore all that. And we kind of like padded the actual useful log here. Start up the job, end of the job. It's printed out that factorial of 10 is this. And if you return, if your handler function return anything, it's going to print the return value in the result. In this case, undefined because it's a void return type. Yeah, that is it, and that is everything I wanted to show for the demo. Cool. Let me check once more to see if there's any questions. If not, we will do a deep dive into what is going on behind the scene, how we're using CodeBuild, why we're using it, how is it all hooked up. But if you need to jump, like, feel free. There's you have everything you need to use the job, and this video will be recorded, so you can come back later to see if anything that's you want to understand a bit more in detail. You can catch this video on YouTube after. Cool. All right, let's do a behind the scene dive into what is going on. Let's start looking up the code in the same order that we created them. We first created a job construct. Okay, let me shift my screen and let me move this screen to the right. This is our application. This is our application code. Sorry, this is our code. We'll move it to the right, and I'm also pulling up. This is SST source code. I'm putting up the SST source code on the left, so we can have the side-by-side view of what we'll look at. One line on the right and see what did that line do on the left. Okay, we create a new construct called job. Let's take a look at the job construct on the left. Job takes a bunch of props, very similar again to our function props. A subset, I'd say a subset of function props, and memory size timeout. You could disable the live lambda deploy, lab lambda development, config, environment permissions. We're leaving environment here, but not recommending to use. You could use environment if you want to set debug flag or something. But for anything you actually want to, if you want to reference like a topic ARN or bucket name, definitely use config. Cool. We'll step into the constructor of this job construct. At the very top, we are doing a check to see the ID for the job needs to be unique across the entire app. When you on the right, if you do new job, my job, this is in CDK. In CDK. This is called the ID of a construct, right? The ID of the construct in CDK only needs to be unique within the current scope. And what the scope is, it's imagine your app is a tree where you have an app, and an app has a couple child called stacks, and each stack has a couple construct. In this case, it has an API construct, has a job construct. So all of these are the children of the stack. And so in this case, my job only needs to be unique within the children of the stack. But we found it, it could be very confusing that if you have my job in one stack and my job in another stack, and also in your application code, right? When you say I want to invoke my job, you shouldn't need to specify like I want to invoke my job in this stack. So we thought, let's just make it easy. Let's make it unique across our entire app. And on the left, this is doing the checking, right? So we are checking, making sure that the name is unique across your app. We can ignore most of this. Okay, now it's creating a code job project. Take a look. So what the code job project do is, it's really just we're using this AWS service called CodeBuild. What is CodeBuild? CodeBuild it's really like AWS version of like a CI service, right? It's a family of code services. You have CodeBuild, code repository, CodeBuild, code pipeline. So you can, so a CodeBuild, imagine it to be, or what it was designed to be is you have this container, you can tell it what is Docker image to use and what script to run. And usually for a CI job, you say, hey, I want to use this image and run a bunch of this script, run a build, run a deploy, And now you have code pipeline where you can stitch together a couple of CodeBuild jobs, or you can also have lambdas and other stuff in there. And with CodeBuild, you have let me just pull up the CodeBuild page we're looking at, right? If you were to create a new CodeBuild project, you can see, oh, this CodeBuild can be triggered by GitHub, Bitbucket, right? It's really like initially designed as a CI service. You can specify your own. You can use a managed image or your own Docker image, and CodeBuild has a couple images that come with it. Let's say if you want to use Ubuntu, it has different versions of their base Ubuntu image, and it has artifacts. For CI job, you can say, okay, after my thing, do a build, I want to store the build artifact in S3 bucket or something, right? All these are very specific to a CI service. But the reason we end up picking CodeBuild is because it's a serverless service, very much like a Lambda function, right? If you just want to run something, you don't have to worry about setting up VPC and setting up a cluster, right? You can just give it some code and it will run it for you. We find that to be very appealing. So we end up picking a CodeBuild. So now you know what the CodeBuild is. You can see that for the image, we are passing in this Amazon AWS Lambda node image. This is a Docker image, officially created by AWS. Let's see, what's this? Right, go on Docker Hub. You can see this is published at AWS, and it is provided as a base image for Lambda containing all the required components to run your functions, package the container image on Lambda. But in simple terms, it's a runtime environment. It's a Docker image we found with the runtime environment that's the most similar to the actual Lambda's environment. Okay, so we're using that image, and compute type is a CodeBuild has a couple configurations for the memory size. So 3, 7, 15 GB, and 145 GB. And the number of CPUs you get the number of CPUs, CPU scale of vCPU scale up depending on how much memory you give. I think 3 GB has 2 vCPUs, 5 GB, 7 GB has 4 or 8. So you kind of scale up proportionally. We are setting some environment variables. And this is how we set environment variables in CodeBuild. We're doing the exact same thing for functions. So we're just trying to do the same thing here. And you set a timeout. CodeBuild has a timeout that has to be longer than 5 minutes and has to be less than 8 hours. So there is still a timeout limit, but it's 8 hours. Should be more than enough than most of the job you need to run. And how Lambda, you are passing in a piece of code to run, right? Over here, that code is called a build spec. Again, it's a bunch of command you can run. We'll show you how we are packaging that. So we created a CodeBuild project. And then what we deploy is a bit different depending whether we're doing SSD start and SSD deploy. Let's look at SSD deploy real quick. When we do an SSD deploy, we also deploy this called a CodeBuild invoker. what a CodeBuild invoker is this Lambda function that invokes this the CodeBuild job. So on the very high level, you can imagine a job has two AWS resources behind the scene. One is a CodeBuild project that's actually running it, and there is Lambda invoker, which doesn't really do anything. It just invokes a CodeBuild job. If you look at where this code is coming from, it's our Lambda invoker. Again, doesn't do anything. You just make an API call to CodeBuild to start the job, and then you'll print it out to say, hey, the job has started. Exactly what you were seeing right here. Okay. The reason we're using this invoker is it does two things. One is able to package the payload from taking it from environment variable and feeding that into the CodeBuild job when it starts. But more importantly, we want to have a Lambda in front of a CodeBuild so that in your application code, when you do job.run, you're not dealing with CodeBuild directly, right? Because CodeBuild is just a service that today we find it to be the service that best fit to be used as a worker for the job. But later on, we might switch to ECS Fargate or some other service. But we want to hide that implementation detail from you and we don't want to change any API how you would run the job. So intentionally, we're building an abstract layer on top of CodeBuild. So to the end user, it shouldn't really matter what is using behind the scene. Just we hope trust us to pick the best service that can does the actual work. And to you, you're just interfacing with this API layer, which is this Lambda invoker. Cool. And you can look at this Lambda invoker, right? Its only jobs to invoke the CodeBuild job. So the permission it has is really just one permission to start the build, and we are passing in the project name to it, so you know which CodeBuild project to start. So after it, so now so far we created a CodeBuild job, we created an invoker. We have done everything we need to create. Now we're going to build the CodeBuild project code. The project code is again very similar to how the Lambda functions is building your code. It uses our bundle component that's to build it. If you go into the functions, now let's switch to the function construct. You can see that if you use all of our Lambda functions are also built using the exact same command, right? So your code is built in exact the same way. So any piece of code, if that runs in a Lambda function, and you can use it directly inside the job. Only limitation so far right now is that it only supports Node 16, and it has to be bundled using ESM. We try to make it very we want to restrict what it can do upfront to provide a good experience. But again, message us in Discord if you want to use Python or other runtimes for this. I'd assume Python would be a very people will bring that up a lot, because if you run any a lot of people mention, right, they could use job to run machine learning code, and a lot of them are using Python. So yeah, definitely let us know. So after the code is being bundled, remember, if you go back to the CodeBuild console. Sorry, let's go back to where we created the CodeBuild job. All right, so we create a CodeBuild job here, and you look at how I mentioned for Lambda function, you're just giving it a node function, like a JS file, and just say, hey, run this JS file, call this function inside JS file. CodeBuild doesn't really take a file directly. It takes a list of commands. So we just need to create some commands that wraps around this file to invoke it, right? Very simple. What we are doing here is we're just printing something out. After your code is bundled, it's all built. We said we're gonna go import the function inside the JS file, JSON decode the payload, and do invoke the module function with the payload, and that's it. Really, all the magic is done between these 3 lines. These 3 lines is really converting a file into 3 bash commands that you could give it to the CodeBuild to run. So we're just wrapping around your code so that you can run directly in CodeBuild environment. A couple questions. Devin's asking, what are property use cases for a job? Obviously, long-running tasks, but meaning some more examples. Yeah, it's there. Let me just say everything what I was told when I was asking people. Would you be interested in a long-running job? Some people mentioned they're using like a legacy piece of software where it's really just one process. You run it, it's some sort of crawler you would run for like 20, 30 minutes, and there's no way to chop it up into smaller pieces to run it in 2 steps. So what they're doing is they're running inside Fargate. He says Fargate. And some people, they need to insert load a large amount of data into a database, and it's not like a DynamoDB, or you can break that data into smaller chunks and do an insert statement, do a bunch of insert statements. It's really like a database import command, which is really just this one giant import command that load a bunch of stuff in the file into this database, and that would run for quite long, longer than 15 minutes. So these are the jobs that people are just not possible to break it up into smaller pieces. There are also a class of jobs where you are able to break into smaller pieces, but these scripts are like one-off scripts that you don't want to invest the effort to orchestrate, design like a step function, a workflow just to do that job. So people will be like, okay, screw it. Let me I just need something to run it. Like an example from one of the folks in our community is saying that they had like Google spreadsheet, a really large spreadsheet. They keep appending stuff to it, and each sheet has you can copy and paste some the images in there. So what they want to do is every night or every so and often they want to have a script that goes through every row of the spreadsheet and then for all the field where there's an image, they want to get the image, process it, and then store it somewhere. They could break the whole thing up into using step functions and then fan out using a bunch of Lambda function handling each row. But then you might run up against API rate limit and a bunch of really annoying stuff. So they're like, let me just write. I wish I could just write a for loop. Because I don't care about performance for this. I just want to write a for loop that just loops through each row, loops through each image, just do its thing, right? Just let me know when it's done, right? I don't care if it takes 5 minutes or 2 hours. So that is also a good use case for a job. Sarah is asking, is that Docker image choice configurable, or is there plans to make it configurable? It would also be great to be able to choose between Fargate versus CodeBuild in case you are already integrated with Fargate. Yeah, the Docker image right now is not configurable. Right now, I think we are taking one extreme of only support Node, only support and the Docker image is really very similar to the Lambda Node 16 runtime. It's meant to run a function that you would have run inside Lambda, but now you are running it here because it takes longer than 15 minutes. On the other extreme, we are able to open up all flexibility. You can give your own Docker image. You can even run Docker inside this Docker. CodeBuild has this flag called privilege flag. You can run like Docker in Docker. You could provide your own bash script. It doesn't need to be a function. You can be super flexible. Right now, we're leaning towards one, and then hopefully we want to pick up, the use cases, what people are using this for. If a lot of people are interested in almost having not even job related, they just want a Docker solution, we might build that out as a separate service. And very likely we might use Fargate for it. Just there isn't enough clarity on our side just to make everything configurable right now. But yeah, if our use case, this is not you're being blocked, just let us know. And between Fargate and CodeBuild, right now we're picking CodeBuild because of 3 reasons. I kind of shared in the doc. Let me pull up the doc. The doc, I can share the link to the doc in the chat. Right? Why using CodeBuild instead of Fargate? One is the use case we have in mind after talking to folks is I just want to run something quick and dirty, right? I don't want to configure a VPC, and right. So CodeBuild, and I don't want to manage a cluster. So we find CodeBuild to be very easy to start up, like very easy to visualize. It's really just like you have a Lambda function, now you have a CodeBuild project, right? It's almost one-to-one mapped. There's no cluster, no VPC or other supporting infrastructure. And CodeBuild also comes with 100 free build minutes, which you don't get for Fargate. So if you want to play around while you are designing your job, right, you could stay within the free tier. And also CodeBuild, for some reason, CodeBuild is blazingly fast to deploy. I was looking at the CloudFormation, the event. When you deploy CodeBuild, you will create it. When you make an update, the update can be made within a second or 2-3 seconds. Whereas any changes you make to an ECS Fargate cluster, it could take half a minute to a minute to deploy. But again, if we want to, right. But CodeBuild does have some limiting factors where Fargate could be cheaper if you're running something very often. So we are not bind to CodeBuild. So that's why we create this Lambda invoker on top of CodeBuild. So we are, in the back of my mind, maybe we're going to switch to Fargate at some point. So I'm definitely leaving that option open. Cool. Where were we? So we showed that, right, the function, the CodeBuild job is being built exact same way, as a Lambda function. And we're just wrapping your Lambda function into a script that CodeBuild can run. Next, we are creating this. We're creating a config parameter that just stores the name of the invoker function. Where this will be used is on the right. Again, on the right is your application code, right? When you run job.run, we'll pass in my job. It needs to know what is the function name for Lambda invoker for my job. So this function will be able to find it inside its using config. We'll look at what job.run does behind the scene. It's pretty much looking up this config parameter that I created. So we're just creating it to be used at runtime. And let's say if you pass in some permissions or config, it's going to grant the CodeBuild those config and those permissions. Cool. So that's the construct, right? Very simple. A Lambda function, a CodeBuild project. Cool. So we looked at these lines. When you do a new job, what is being added to your CloudFormation stack. Then when we do attach permissions, it passes in a job. And what it does is, if I look at permissions, so we're looking at, I'm looking up the permission file, which is the file that that's, you know how we do attach permissions, we can pass in an array of, you can pass in a string, you can pass in a construct. So we have this permission file inside our resources package, which does the decoding of where all the magic happens, right? You're decoding the string or the construct into the IAM permission behind the scene. In this case, if you pass in a job, it's going to grant a Lambda permission to the job invoker Lambda's function ARN. Right? So what that means is your API route will be able to call Lambda invoke to invoke this the job invoker function, and the job invoker function again is going to trigger the CodeBuild, so it works like that. One thing I want to point out real quick is if you had like a SNS topic, right? Usually what we need to do to grant that, if the API needs to send an event to the SNS topic, you usually need to do two things. You need to grant the permissions to topic, right? Similar to what we're doing here, attach permissions. You also need to pass in the config for my topic ARN or something, right? It needs to pass in two pieces of information. You need to pass in the config so that so this passes in the actual ARN of the topic. So in your application code, when you call the AWS SDK to send an event, you need to pass in the topic ARN, right? This is how you pass it to your Lambda function. But note how we are not setting a config for the job. How does API know what the name of my job is, right? How does it, so when your application code, when you do job.run my job, how does it know the Lambda function name that it needs to do to invoke it? If I go into the function, this is something we are starting to do differently for jobs. When you attach permission, so when you attach permission to the API, so for each API route, we're calling attach permission. It attaches permission, it attaches IAM permission, which we have always been doing. Now we add this thing saying that if it is a job, we add the config automatically. And the config is this job parameter. If you go back to our job construct, it's this parameter we created. Why are we doing this differently for a job? It's because job is a very high level construct. And when you give permission to the job, we know you want to invoke this job because there's only one way to use it. There's only one thing you can do. When you grant a permission to a job, there's only one thing you can possibly do to this job, right? But unlike what you could do with a bucket, when you grant permission to a bucket, you might want to remove it. You might want to, you can do all different of things. It's a very a low level AWS resource. But the job concept is like a very high level. So we have like full control of it. So when you say, hey, give me permission to job, we know exactly what you're going to do, what you want to do with it. So, and to do something with it, we know what information, right? Because we are also writing this a client helper on the front end. We know exactly the information we need behind the scene for this job.run command. So when you grant permission, we can pass that in already. We can pass in all the config we need to run it on the front end. Sorry, not the front end, application code, right? So we're doing that automatically. So you don't have this cumbersome thing that every time you need to pass a topic in, or like you need to access a bucket, you need to access a queue, you need to pass that into both the permission and create a config and pass into the config, right? If you have used SST before, you probably found this pattern to be very redundant. And so for the job, right, we made it so that when you grant permission, we can guess what config you need, and we'll create that for you behind the scene. And this is going to be a pattern we want to start applying to all the construct we build from now on. And we might retroactively also apply this, bring this idea to our existing constructs. For example, if you have a S3 bucket, or you have a SSD bucket, if you grant the permission for the bucket, we know that for any S3 API call you need to make, you probably need to pass in the bucket name. Any S3 SDK call requires a bucket name, right? Since we know that, we should have just created a parameter for you when you create a bucket, and then when you grant the permission, we will also set the config. So you no longer need to do this anymore. You just need to set the permission, and we'll pass in the config for you. Right now, it's hard for us to do some of these magic. I wouldn't call it magic. Some of these convenience things behind the scene is because bucket names is not app level unique. So when you say bucket name, if two buckets from different stack have the same bucket ID, like how we have a job ID here, the config name could thrash. So we don't have a way to reliably create a unique config name for every bucket automatically. That's why we are making the job ID unique, so that we can create a parameter for you automatically behind the scene. We can pass that parameter into config automatically behind the scene. And application code, when you say I want to run my job, we can look up that parameter name automatically behind the scene, right? So this is the beauty of having this ID unique across app. Cool. Okay, let's just. All right. Next thing, let's look at. So this right now, I think we just went over everything on the infrastructure side. Let's look at our application code. First, let's look at right. What's this type thing? How is it able to make it type safe across here, and when you run a job, how is it type safe over here? Let me open up all the cool thing that's going on is inside the node package, the front end package. We close the irrelevant files. Okay. So this is the file we have for. If you look at the path of this file, it's package node source job. So we are looking at our node package job subpackage. It defines two interfaces up top. It has job names and job types. and all the other types that's getting assigned to, when you call job.run, everything is figured out from job names and job types. Same as when you create a job handler, as you're doing on the right, all the types are figured out from job names and job types, and we are auto assigning the payload the correct type. Let's see how is that being done. So job names is being code genned by SST every time you build. When your SST start is running, it's building every time you save your stack code, it builds automatically. And when you do SST deploy, it does a build first. Or you can call SST build to build it. So every time you build, it generates this interface called job names. So on the right, let's go into our app. Let's see what is being generated. It's generated and saved inside your node modules at types, serverless stack node, job is being generated here. So this is a generated type. And it's saying that there's one job called my job. Let's quickly look at how is this file being generated. Let's go back to our job construct. Our job construct at the very bottom, there is, okay, not that bottom. At the bottom, let me collapse everything. At the bottom of all the public methods, there is this CodeGen types. What it's doing is it's appending, to this path. It's creating a job.d.ts and it's adding that into the index.d.ts. And what it's doing is, we use this declare module trick, which is you import something. You can import an interface from a package and you can override it or extend it. In this case, we're extending how the job name was empty when we defined over here. We are extending that, and for every job, we are going to create an entry called name of the job, string type. So that's how this is generated. Okay, so we have job names being interface. That knows all the name of your jobs, of the jobs in your app. Let's see how's the job type being generated. It's actually generated by you, or like what we just did. Again, we're using, this is the job handler file. In the job handler file, remember how we did the same declare module trick? So we are importing it and we are like, hey, we're going to override job types. And we are defining the type over here saying, my job can only take one argument called num, which is a number. Right? So you can imagine job names are being auto-generated by SST. Job types, you are responsible of defining the job types. And we are doing some TypeScript magic to say that when you call, let's look at job handler first. When you create a job handler, the name has to be the key of job names, right? So you call my job 2, you're gonna type error because you didn't create my job 2 inside your stack code. You only have my job in your stack code, so this can only be called my job. And the payload is going to be job types, which you defined over here. You can take job types and then find the one that's with the key being the name of my job. So over here is going to look at job types, and then you're going to look at my job, and you'll be like, oh, it's a num. and it must be a number, right? That's how this is typed. This is type safe. This is automatically typed. And every time you do payload dot something, that's automatically type checked. Okay, that is the how job handler is being created. So as you can see, we're not doing anything in the job handler. Job handler, we're really just wrapping around almost like what looks like a Lambda function handler, right? It just takes an event. The only reason we are wrapping around it with this thing called job handler is to assign proper types. So it makes your life easier when you are using payload. Okay, now let's look at in our API. This is, again, this file is the API handler for API. And in our demo, we made it call job.run to invoke the job. And again, similarly, this run has a type definition of the name has to be one of the guys inside job names, which is my job. And you can optionally pass in props, and the props has one attribute called payload, which is also optional. But if you do pass it in, it has to be of job type and has to be with the key being the name of the job. So that's how we're getting the type safety over here. So again, this is type checked. This whole payload is type checked. Let me take a look at my code, my note. I think that is everything I wanted to go over. We look at behind the scene for the construct. We look at behind the scene for the permission system for the jobs. We looked at behind the scene for how you define types and handler, and behind the scene for invoking the job. So I think we pretty much went over everything. The last bit maybe I want to share is if you go back to the job construct, the part I kind of skipped over was if you created, if you're running SSE start, we are doing one thing. And if you run SSE deploy, we're doing another thing. We went over, creating this invoker that just calls a code build, all this logic under SSE start, SSE deploy. For SSE start, what is going on behind the scene is the invoker function. It doesn't call code build anymore. It sends request to your local. So using the same way how live Lambda development works. So when you're running SSE start, remember when we were running SSE start, when you were running something, the logs gets printed out right away. That's because all the code is running on your local. In this case, we're not using the code build job at all. Everything's happening on your local. So that's the difference. Very similar to what we're doing for live Lambda deployment for Lambda functions. So now you can imagine when you run SSE start, your SSE start is almost like a virtual Lambda runtime. It's also a virtual code build runtime, right? So whenever and you might get called to run a Lambda function locally, and you might also get called to run a code build job locally, and that's the difference between local and deployed version. And I'll take a look at my notes again. I think that is everything I wanted to cover. I'll leave some time, a couple minutes for a Q&A, and guys feel free to drop any questions you might have. As I wait for the questions to come in, I have a couple questions that I kind of gathered from our Discord community in the past like week or two, and I kind of want to share them. Most of them I documented in the in our doc already, in the long running jobs doc. First, I think we went over a lot of these concepts already. Let me just kind of restate, just quickly go over this. When should I use job versus function? I can use job, think job as if they're just functions. Just if it needs to take longer than 15 minutes, use job. If shorter than 15 minutes, a function will do. Note that job they're running inside CodeBuild. What happens when you run a job is, first of all, AWS CodeBuild, they manage a pool of these, containers, and this like EC2 instance, and then containers inside them, and when you want to run a job, you might not be able to run it right away. Usually they run it for you, but maybe 1 in 100 times they might not able to run away, so your job might be queued. So there are some time you have to wait over there, and then after it's off the queue. Usually it might be queued initially for 1 second or 2 seconds. It should be fairly quick. Sometimes you could go for like a couple minutes, very rarely. After it's off the queue, the CodeBuild needs to download a Docker image, right? That process is almost like a code start, right? If you imagine what code start is for Lambda function, a lot of that time is downloading the file from S3 and zipping it and spinning up the Docker Firecracker environment. In this case, it's very similar. You need to go fetch the image from Docker Hub, spin up the Docker container, and then and that is the code start time. And the code start time is relevant to how big the Docker image is. And I think the official Lambda Docker image that we're using is about 140 megabytes. So it takes about 30 seconds to do this entire boot up. So you can imagine the least amount of code start right now, given our current architecture using CodeBuild, the least amount of code start is 30 seconds. So don't run anything, if you need a response back right away. But given that it's meant to run long-running jobs, we think 30 seconds it's not that big of a deal to wait for. But just keep that in mind. Is job a good fit for batch jobs? Right. This is very interesting, right? If you're familiar with AWS batch or step functions, right? They are almost meant to run batch jobs. The definition of a batch job is it's like a coordination process. You have something to run. The first steps, figure out everything to run, break that down to smaller steps, and each one, if you can get them down to like a single task that should be run in finishing a couple seconds or a couple minutes, give that to a Lambda function. What this allows you to do is, if you need to do some batch process over 100 rows of a file, you could load the file, read each line, and as you're reading, give each line to a Lambda function, and then they will finish right away. So almost you can manage all hundreds of the jobs, 100 of these smaller steps. You can run them concurrently, right? Should be super fast, right? That is the ideal world. But in real life, it's a bit more complicated than that, right? You need to handle what if the initial step can load everything, right? So initial step you can only load like chunks, and then every step they are doing work concurrently. What if they need to make third-party API requests, and that third party, this, by the way, this is what we heard, like a lot of people, what their issue with running dispatch jobs concurrently is they need to hit some third-party libraries, and they usually get throttled. And when you get throttled, it's kind of nasty to implement It's not nasty. It's a bit of work. It takes a bit of knowledge or AWS knowledge to implement the retry system and do exponential backoff. And a lot of them are just like, this is really a side thing I'm doing. I don't care about performance. Just let me. I don't mind processing each row one by one, and I don't mind, you know, it being slow. So just I have a function that worked already that used to work on when the table had 5 rows. Now it has 1,000 rows. I just want to reuse the same function. Right? Perfect case to stuff that inside a job. But if a job you start to finding, oh, this is actually mission critical. I care about performance, and it runs very often. Definitely look at one of the other options, or let us know if you get a lot of requests. It could be a very interesting improvement on top of job, or we could have a batch job construct just dedicated for that. But the focus there would be how do we coordinate stuff, how do we handle failures, how to handle retry, and so on. Right? Why CodeBuild instead of Fargate? Right? I think I just mentioned, right? Because CodeBuild, you don't have to worry about VPC, you don't have to worry about cluster. You get 100 free build minutes, and it's a lot faster to deploy. And another question I kind of got was, what if my job needs to run longer than 8 hours? It's again, let us know. 8 hours is a hard limit for CodeBuild. If we find people needing to run more than 8 hours, we have to switch to Fargate. Another thing is, sure, maybe I'll mention some downside of CodeBuild. CodeBuild would be, a lot of people think CodeBuild is more expensive than Lambda, right? If you use AWS, if you do step functions to batch everything, run them in parallel, since you're using Lambda functions, they are usually cheaper. No, that's not true. Lambda functions, if you look at a bang for the buck, like how much you're charged for the same amount of memory. If you look at for a 3 gigabytes memory Lambda function that runs for a minute, the cost is exactly the same as a CodeBuild job with 3 gigabytes of memory running for a minute. So you're not saving. You're actually not saving much there, right? You could, since you're running stuff in parallel, it could be run much faster, but you're not really saving any dollars there. Lambda, they are prorated to milliseconds, but CodeBuild jobs are prorated to the minutes. So if you run something for half a second, you get charged for a minute on CodeBuild. But since you're using job to run long running jobs, so this prorated down to a minute or versus a second or millisecond shouldn't vary that much. So cost shouldn't be a main concern whether you're deciding to use job or function. But Fargate could be much cheaper if you're running something constantly, right? Fargate, you're paying for the underlying the EC2. I think they also have the spot instance mode. So if you manage to get that to work, that should be a lot cheaper, depending on how often you run it for. So again, I want to say that if you have something that you need to run on a regular basis, or it's a task that you need to run 100 or 1,000 times a day, yeah, maybe consider looking at, maybe prototype it in jobs, get it up and running first, and then if the cost becomes a factor, becomes an issue, start looking into Fargate. And another question was, right, alongside of what are the use cases for a job? A job is really just to run a piece of code, right? It's, even though it's doing a lot of container stuff behind the scene, it's not meant to run like a web server or anything that's long running, right? It's just perform a task, run a piece of code, and you can only live for 8 hours. Cool. All right. I don't see any more questions in the chat. Uh, so I assume I did a good job explaining jobs thoroughly. And if you have any questions, uh, just definitely contact us in Discord. Right. If you have any issues, use the help channel to message us. And any feature requests, anything, yeah, just let us know. Again, intentionally, we keep the scope very small, but we love to learn more about the different use cases, and then either we want to improve job or create another construct more dedicated to your use case. And I'll wrap it up. All right, thank you, everyone.